Go through chapter 8 real quick. So fluid power schematic diagrams. These are meant to explain the operation of a circuit because that's the whole purpose of a schematic, right? You're given a circuit. How does the circuit work? What is the whole purpose of the circuit? Where does everything need to go? And in what order does it need to be in, right? If I give you a schematic and tell you build this, you are supposed to be able to build it just from the schematics and parts you're given. Yeah? So it should be made of fluid power symbols. Now, the funny thing about fluid power is that we also have added in things like electrical symbols for basic things like solenoids. That's what I was trying to look for. There are devices called solenoids. Solenoids work by reversing polarity. And so what you have is this metal rod that can move either vertically or horizontally, but the electrical current changes the polarity, and that rod moves based on that polarity. Okay? So there is some electrical symbology, but it's generally not a lot. Most of the time, if we're dealing with hydraulics or pneumatics, we're dealing with strictly hydraulics pneumatics. Why? Well, because it's much easier to deal with making something work on its own power set than trying to make it work off a different power set. You know what I mean? In other words, if I've got pneumatics, I'm hooking up pneumatics. Why would I want to go put hydraulics or electrical in it if I don't have to? Kind of makes it a moot point, right? Fluid power is in just about every plant. I won't say in the world because there are third world countries that don't have air compressors and such, much less electricity to run them. But they are in most major manufacturing. Why? Because it's cheap. Honestly, it is. Think about this. I can have a compressor running, or I can have electrical running. Which one's easier to deal with? Actually, pneumatics. Pneumatics is in just about every place you can think of. It's a clean energy source. You don't have to try and find a way to return it back to where it goes. You can just vent it to air, right? It is one of the cleanest energies to use, right? The only thing it takes up, fossil fuel-wise, is generally what? The electricity to run it. And generally, it filters the air out and makes it clean, and what comes out is cleaner than what went in. Think about it this way. What is in the air constantly, especially here in the summer? Pollen and dust. The enemy of all people with allergies, right? So you have a big air filter that's sucking this air through it, and it's processing that air and holding that air and pressurizing that air so it can be used later. But once that air is used, it's vented. It is released back into air. So essentially it makes it cleaner than when it went in, right? So plants can have several thousands of individual systems. And what they're talking about here are basic systems. So something like this, where you just push a button or you turn it on and it automatically works. And it's a very simple system. Or you can have really complex systems that somebody presses a button and it causes a whole assembly line to work. All right. The bad thing is that you have to maintain your fluid power systems. And by maintain, you need to check your hoses very frequently, because what can happen to hoses over time? Huh? They can burst or bust, they can crack, they can break. How many of you have ever used a sandblaster and used like a little plastic hose to kind of try and direct it? What happens to that little plastic bit of hose over time? And I say this because I've used a sandblaster before. So here's how it initially starts, and that's generally how it ends, right? The wall wears away. Why does it wear away? Because you have something abrasive constantly pushing through it, right? So if you have something very abrasive in your lines, you're going to have to change them out more frequently than if you have something non-abrasive. What do we mean by abrasive? Well, put it to you a little bit of a different way. How often do y'all change your air filter in your car or in your house? About every 2 months, right? Now think about an air compressor that's sucking in all this dirty air so it can compress it and then put it through a system. How often do you think you should change that filter out? Minimum of about every month to 2 months, right? So if you don't change that filter out, what's going to happen? It clogs it up. If it doesn't clog it up first, then what it's going to do is it's going to start sucking in that particulate. And if you can't find some way to filter out that particulate before it starts getting to everything else in your system, you've caused yourself a problem. Well, what do I mean by that? Well, what's one thing we don't like is scratches on all our parts. I mean, it's abrasive. It's like having sand in your shoes, right? Maybe you've ever had that issue. You've gone to the beach, you've got sand in your shoe, it almost never comes out, and every time you put your foot in the shoe, what does it do to your foot? It rubs against your foot, it abrades your skin, right? Because it's very rough. Now, think about that high pressurized and into a pneumatic system, you've got an issue, right? So what you've got to make sure you do is if you are ever working with any type of fluid power, maintenance is the key. You need to check your compressor filter frequently. You need to make sure that your parts are still looking okay, because any one thing can cripple a whole plant. What do I mean by that? Well, you take down a big machine, you are kind of done for the day, right? But the most simple system you can think of, well, I don't know how simple it is, but how many of you have ever worked on the brakes in your car? That is one of the simpler systems, right? Essentially, you push on the gas pedal and what it's doing, on the brake pedal, and what it's doing is it's sending that pressure, transferring it into the fluid pumps that are connected to that pedal, and that is transmitting into the brakes. Okay? So this is a fluids power system. This one is what? Is it hydraulic or pneumatic? What is it, pneumatic or hydraulic? It's hydraulic. How do I know? Well, there's several different ways I can tell. First of all, this is the sign for a tank down here at the bottom. Second of all, there's your filter. Why do we have a filter? Well, why do we have a filter in our car? Well, we have an oil filter we have to change every 5,000 miles. Strain out the junk and the gunk. If you have ever seen an old oil filter that's been broken open, that sucker's nasty. Why? Because what it's trying to do is all the little particulate that's all in your system, it sucks it down into that tank and it's trying to keep it there. By the way, you also have a fuel filter. Does the same thing for the fuel in your car. So you have your filter here that is being pulled up into your pump that is controlled by its motor. This right here is your pressure relief valve, because if you pressurize hydraulics too much, what happens? Anybody ever done that? You better hope that thing releases, because if you overpressurize the oil in your car or in your truck or whatever vehicle you drive, you're going to blow every seal you've got. Y'all know what I mean? My brother did that once. He put like 6 quarts of oil in my dad's old truck. He blew out every seal in that truck. Yeah, he's not that smart, but. All right, so you have pressure relief valves to try and prevent that. However, if you've overfilled your whole system, there's really not a lot it'll do to save you. This comes up to a manifold. And this manifold leads it to your what? This is leading up to what's called the directional control valve. We talked a little bit about it last time. From there you go to your cylinders. Another clue that should have told you hydraulic. This means pressure. P means pressure. T means tank. What do I mean by tank? It means that it's sending it all to tank. Right? Because it's hydraulic. Anytime you have hydraulics, where's everything got to go back to eventually? Got to go back to that reservoir or tank. Okay? Does that make sense? So composite symbols. So we tend to take in hydraulics and pneumatics and just blueprint reading in general. You know, saw this with a little bit with the electrical. Is we tend to take symbols and we tend to start kind of stacking them. Why? Because the more we stack them, the faster we can draw them, get it done, and the less what? Amount of time and space, right? The less time and space that I take up with this symbol, the better off everything will be, right? Because what is the biggest old saying? Time is what? Time is money. You can be faster, you can make things easier on yourself, why not, right? So we stack symbols. All right. So this is a symbol for a double pump. So we've got a manual control, we have a variable displacement and a fixed displacement pump with their motor that runs both of them. Questions on that? I will say this, the most common pumps and compressors are typically one direction. Why? Because generally you need fluid flow only in one direction. With pumps, if you generally have an emergency valve that you can dump all the fluid to tank if something happens. With pneumatics, you generally have a way to vent all the air out if something's going wrong and you need to do that. So the most common ones you'll probably see are the fixed displacement single direction pumps. So this one's showing you a 2-position valve. So most fluid power controls are composite symbols like we just said. So this one is showing you that it's got a spring, that it's got two different positions. Now how do I know that's two positions? Well, position 1 is showing me it's got 4 ports. It's also showing me that those ports are closed off in this position. Then you've got the secondary position, which tells me that my pressure is going to go to 1, and everything in 2 will be coming to tank. Okay. And then it's got a manual control. So again, it's a composite symbol. It's meant to be stacked. Does that make sense? Why? Because drawing all this together is much easier than trying to draw them in different ways. And it can make a lot of sense. So I'll let y'all kind of just look at this one because how many positions of valve is. So what do I mean by positions? What do I mean by position? Well, it's to have a three-way that you know you guys can see, but I don't. It's got 2 ways. So what do I mean by positions? So this right here is a pneumatic valve. And this guy has 2 positions. He's either left or he's right. Okay? He's just got 2 positions that switch can be in. What that switch does is take the valves and direct them to open or close. So whenever I draw my symbol with these, I'm telling, back up. When I draw my symbols for these, I'm basically saying, well, in position 1, I've got my air going to 2, and 3 is not doing anything. Okay? But whenever I change the switch to its other position, I have to describe what it's doing at that time. So in this particular one, whenever I switch it over, my port 2 goes to port 3, and port 1 does nothing. Does that make sense? So that's what it means when you're dealing with these. Is all you're doing dealing with these symbols is how many different positions can I move it into, and what do those ports do in the individual positions? Does that make sense? Yeah? Okay. So then we have to, whenever we're dealing with these symbols, we also have to deal with what are the operators. This particular one is a detent switch. What that means is that whenever I turn the switch, it locks in place until I come back and do what? So I come back and pop it loose. So I use a button. You got somebody that's got to press the button. That means they press and release, right? So you have symbols for that. You have symbols for these guys right here. These are cam operators. So essentially what you would have is something like the line coming above here, and every time it comes down the line, it's popping this down. Great way to create a counter. And then you have the ones that you don't see. these guys right here. So you have the manuals. These are the ones you're very used to seeing. So push buttons are very common. Levers are common. Those are kind of like your foot pedal in your car. We have spring returns that pop it back out or pop it into a different position. Mechanical rollers I just showed y'all. You have what are called solenoids. I don't have any of those currently, but solenoids are an electrical component. So essentially what you do is if this is my piece of metal, you have something wound around it, like so. When you run electricity into that wire around it, this guy right here is polarized, either positive or negative to one side or the other. It's basically a magnet. So whenever I polarize my current into my wire, it's going to cause the solenoid to move up or to move down within that wire coil, depending upon which way you've got the current pulling. Does that make sense? That's what a solenoid does. And then you have valves like these, which are strictly air controlled. Okay, so what I can do with this guy is I put air here, and then I use these two ports to direct where my air flows. Those are something you've got to pay a lot of attention to when you're dealing with hydraulic pneumatics. What exactly is causing the movement of the actuators insides? What is directing the ports to open and close? Does that make sense? So some different valve actuators. This guy again is your solenoid. You can't really see what it's doing, but you can see where you tie the electricity into it. You've got your roller valve. That's a very common one. You have a lever and you have a push button on this one. All those are doing is creating different ways to move that actuator so that you can change what it's doing. Like I said, you can use the roller lever as a sensor of sorts. You can use it to create a counter. It's one of the cooler ones that you can do because every time it hits, it can count. End of the day, you got your count of how many parts passed it that day. All right, so fluid power circuits. You have to have 5 parts. Why 5 parts? Well, because otherwise it doesn't work. You have to have some sort of a supply. If it's hydraulics, it's a reservoir that deals with a pump. If it's pneumatic, you've got a receiver and compressor. You have to have some form of control with this. Why? Well, because what are you going to do with it otherwise, right? It's not like an electrical system where you can just go flip a switch off or you can just disconnect the circuit. We have to have some form of control with this. Those are your valves. You have to have a load. You have to have something that does work. That's what a load is. It's something that does work. Why? Because what is the point of the system if you're just going to create a loop-de-loop? Right? If you're just going to come out of one valve and take it back to the other valve with a pipe, why did you create the system in the first place, right? We create it to do work. We create it for the actuators. We create it for the motors. We are trying to run something from this. I'll give you an analogy in Electricity, you have to have a light bulb, you have to have something to do something with the electricity that's moving through. Otherwise, what was the point of building the circuit, right? You have to have a complete path for the fluid. Now that's a double-edged thing right there, because on the one hand, for pneumatics, do I have to have a closed path? No. Not unless I've got some kind of a valuable, air like helium or nitrogen or pure oxygen, right? If I have that, then yeah, I probably want to keep that. But if I'm just using general air, if I'm just using a giant compressor in the middle of a room that's sucking in air like crazy, then do I really need to create a closed path? No, I can just let it back out to the air, right? With hydraulics, do I want a complete path? Oh yeah. How much does oil cost? Anybody had to get an oil change recently? How much has it gone up in price here recently? It runs about $60 to get an oil change. What did it used to run? 30 or 40? 20, if I remember right, back when I was a little kid, that was about 20 bucks to get an oil change. Now it's 60. So let's put in different terms. That's not something you want to lose, right? That's a lot of money that'd be going down the drain if you just, I don't know, left it open and just let it go spilling out everywhere. So that's why we create closed system with hydraulics. It's less messy and it's less expensive, right? Any questions on that? So car drum brakes. Now, drum brakes are kind of not, they're still used, but they're also not as used. What have they kind of been replaced by? What, none of y'all work on your brakes? You have the brake rotor, and then you have the brakes that clamp down around it, right? Not a different system, just a different way that they've created it. Because the way that the drum brake works is that whenever you press that pedal, those drum brakes press out into the drum. And that helps slow you down and stop you. The way your current brakes work, for those of you that have newer vehicles or know what I'm talking about, is that you have your rotor, and what your brake pads do is they come down and they clamp down on that rotor when you press the brakes. Neither system is really better than the other, because what are they all relying on is the same technology. It's just drum brakes, the way that they have to push out. I guess they had some sort of flaw in the system that nobody ever talks about. You never know. Or it could just be cheaper to do the brake and rotor system. That seems to be the more popular one these days. By the way, what do you have to do every time you work on your brakes? You have to bleed them, because what do you generally introduce whenever you are starting to work on your brakes? Introduce air. What do you not want in your brake system? Ever. And I mean never ever. You never ever ever want air in your brakes. Why? Because air is compressible, brake fluid is not. What do I mean by that? How many of you have ever done a belly flop? Right? Is fluid compressible? No. Physics say no. You hit that water hard enough, it will knock the air out of you. Fluid is non-compressible. Air is very compressible. Okay? The simple hydraulic system, this one's foot operated. It directs fluid along the lines when you press it and applies pressure to the pistons that press against the brake shoes. Press the brake shoes against the brake drum. Same thing with brake pads. Like I said, I don't know how many of you have really worked on your brake pads and the rotors. But let's say these are the rotors, here are the pads. All the pads are doing is just clamping down. And you can get quite a bit of force with it, right? So here's some different components. You have what's called the, if I remember right, those are the calipers. No, that's not the caliper. Oh, that is the calipers. Okay. And then you have you have two different types of cylinders with this, guys. I can't remember which one that one is. I think it's either the master or the slave, but master or slave cylinder. You have well, they do show you. So if you look right here, this is your rotor. Which, by the way, whenever you change your brakes, you're actually supposed to either change the rotor or do what? Huh? Turn it. What does turning it do? Well, eventually you get all this crud on the outside of these rotors. What it does is bring it back to true. Bring it back into words, huh? Brings it back to level. Thank you. Okay? So, and then you've got the caliper, and inside the caliper where your brakes sit. Most calipers, not going to get into that. You have your brake fluid reservoir, which again, you need to make sure that whenever you work on your brakes, you bleed them off. Bleed out any air that's in them. Why? Because any air is going to cause you a lot of problems. So this one is where the inside of a brake drum, you can kind of see that. So whenever you press the brake, these cylinders extend out and press the shoes against the drum. So. All right, so this one is a pneumatic circuit. So let's start here down at the bottom. I'll go ahead and tell you this. This is your air source. That is a common symbol for air source. Why? Because drawing the compressor and all that is kind of a pain in the rear. So we've been able to narrow it down to just air source. Not to mention your circuit could be on this side of the factory and your compressor's all the way over there. Hydraulics, you don't really want to have too much distance because you can lose pressure at times. Pneumatics, pressure is consistent pretty much. All right. So if we're identifying the symbol, first of all, what kind of symbol is this? Not so much pressure control, directional control. It is a directional control valve. All right. This particular one is actually the one I was showing you earlier. It's what is called a 5-2 detent operated. Now, what do I mean? Okay, so I've got 5 ways for air to come in or exit this particular valve. Okay, I've got 2 positions. That is what This is why that's called a 5-2. So it's 5 ports, 2 positions. This is what I mean by a detent switch. You can see the little notch on that. What that notch does is once you flick that switch into position, it locks it in place. Okay? All right, and what are these two real quick? Not solenoid. Those are your linear actuators. That's what those guys are over there. So these guys move in a straight line. This particular one is connected to a cam operated. So if you remember that little lever that moves up and down that I said you do a counter, that's what that is connected to. So when this guy comes out and hits this, it is shifting to where its normal position is leading up to this cylinder and pushing it out. When it shifts over, it releases it to move back. This up here is a single action cylinder with a spring moving it back into regular position. Questions on that? Okay. Differences. So hydraulics, you have to have a closed system. Why? Because open systems would get very expensive very quickly. Pneumatics, you can use an open system because it's just using air. It's using atmospheric air. So it does not need specialized anything. It does not need to go back. Hydraulic is a liquid of some type, generally made of crude oil. Why do I say generally? Well, because technically, if you could make water truly viscous, that one would work too. Water is generally not used because it's not thick enough. Okay? That's why we generally like to use oils and such because they're very thick. Right? They like to stay together. Water just likes to go everywhere, doesn't it? Truly. I mean, if you've ever, take oils like cooking oils versus water. If you pour water into a pan, what's it do? It just splatters everywhere, right? What does oil do? It likes to come down at a certain speed and it just spreads out on its own, right? Fluid has to return to the reservoir. Tank and hydraulic, air is vented to atmosphere. All right. So let's looking at this. What is number 1 here? That is your tank. What is number 2? It is your pump with the motor. Okay? In this particular case, the motor is there as well. All right, what about number 3? This actually is in your book, guys, so. So what is number 3? Go ahead. Hmm? Number 3 is a pressure relief valve with a gauge to kind of tell you where the pressure is supposed to be. What about number 4? It's your directional control valve. Specifically, it's a 4-2 with solenoid control. Okay. What is number 5? It is your cylinder. And what is number 6? It's another relief valve. Now, why do hydraulics need pressure relief valves? Because, like we said earlier, fluid is non-compressible, right? That's why whenever you take your hand and you slap on top of a piece of water, what happens? It kind of stings, right? Does the water necessarily move? No, not for the first second or so, right? So when you slap it down like that, what happens? It tends to try and bounce back at you, right? With fluid being non-compressible, if you put it at too high of a pressure, you risk blowing your seals. So the way we have gotten around that is by putting in pressure relief valves. Because what those do is direct any excessive pressure and fluid to where? Sends it back to the reservoir. Okay? All right, so I don't know. So should be pages 116 through 118 in your book. So you might want to kind of bookmark those particular symbols because those could appear on your next test. So one of the symbols they don't really show you is what we call the service unit. Because with pneumatics well, this is mainly for pneumatics. With pneumatics, we pressurize everything. Why? Because air is compressible. Just listen to how you pull air into your lungs and compress it so that it goes into your bloodstream. Believe it or not, that's kind of interesting way to do that. So this prepares the air before it gets into your system. We have several different ways that we do this. The first and foremost is we always have a secondary filter before you get to any components. Why? Because we want to filter out anything that might be in it. Water, dust, dirt, whatever, right? If it's gotten past the filter on the compressor, we don't want it in our system. Why? Because it messes up the seals on all your pieces, right? It can score. What do I mean by score? I mean that this was my cylinder. It can leave small scratches in it. Now, small scratches don't sound like much, do they? I mean, heck, small scratches, why we care about that? Over time, those scratches mean you're losing pressure. And the deeper the scratch, the worse it is. Right? So that's why we care about scratches. That's why we try and keep debris out of our system. We also try and keep water out, because what do we have a big problem with here in the summer? Humidity. It's the part where you walk outside and you just about sit there and go, I'm breathing water. Because you're not breathing air on some of these days. You're breathing what? You step outside and it's like, okay, I need gills. You need something to help you breathe the watery air. So you have to have some way to pull that water out. Why? Because water causes what? Water causes rust. Rust is not our friend. Rust is evil. So once we've cleaned the air, we do a few different other things, but one of the other things we tend to do is we have what's called a lubricator. Why? Because dry air is fine, except that you have to go back in and manually lubricate your parts, or they've created a clever device whereby it lubricates it for you. It's like a hose attachment, right? Any of you have ever seen the hose attachments that you add to your garden hose to help fertilize your garden or your grass or whatever? It works similar to that. What it does is it mists oil into the air, so thereby you don't have to oil your parts. They get oiled from the air that's being put to them. And so on and so forth. Any questions on that, guys? Any questions on hydraulic or pneumatic cymbals in general? You might want to bookmark all of them just to have them at hand. Okay? This was a rather short chapter. I know. Go ahead and stop this right there.